Hello and welcome to our APRA CPS 230 series of video blogs, helping organisations to understand how they can automate and streamline the technology risk management processes required to achieve operational resilience. In this video, we will discuss the need to conduct comprehensive risk assessments and ensure that mitigating controls remain effective as required by sections 28 and 30 respectively. I'm Marc Woolward, the CTO at vArmour, and I have several decades' experience of managing technology risk within complex mission-critical environments. The basis of any effective risk assessment is timely and accurate information, which for vArmour customers is provided by Relationship Cloud within the map. This information enables service owners to identify specific areas where risk tolerances are breached, and also to encode policies and rules that monitor for breaches of the risk tolerance as risks and services change from day to day. And once controls and procedures are applied, it is critical to ensure they continue to be effective. By establishing baseline behaviours and enabling the definition of control objectives within the rules engine, vArmour Relationship Cloud can notify service owners and risk managers as material changes and violations occur. This approach facilitates an effective closed loop within an organisation's risk management processes without overwhelming teams with false positives and noisy alerts. Coming back to the 30,000 foot application view, we can immediately see that there are several alerts associated with a number of applications, including the RiskCalcs app, which is a dependency of the critical business operation mobile banking. Applications with alerts can be identified where objects are outlined in red in the map. These alerts have been raised by Relationship Cloud where risk tolerances coded within the rules engine have been violated. Generally, those alerts are delivered to customer SIMs or incident management systems to initiate a remediation workflow, but we can also see them in the alert browser at the bottom of our window. In this example, we can drill down to assess a couple of the issues highlighted as the relationship between two downstream systems accessing the predictive pricing function within the RiskCalcs application. First, I want to take you through an example of RTO inconsistency. So if we click on this relationship between real-time pricing and the RiskCalcs application, we can see an alert that's been raised, or one of a number of alerts, that show access from the real-time pricing system, which has an RTO of 1, to the RiskCalcs system with an RTO of 4. So that dependency is likely to indicate that the RiskCalcs system, were it to fail, would recover too slowly for the real-time pricing application to meet its impact tolerances. To learn a little bit more about this, we can just drill down and we can understand the shape of the dependency. And what we can see here is that each and every one of these dependencies demonstrates the same alert, because that's an RTO mismatch between the systems within the different application functions. And again, we can quickly validate this here by highlighting the systems with an RTO of 1, which is the real-time pricing system, and then highlighting the systems with an RTO of 4, which are the RiskCalcs dependency. Okay, so we've just encoded a policy that allows us to identify RTO mismatches, and we've just worked through the workflow of what you would do when an alert is is triggered. So very, very quick to receive the alert, get the information you need, and then validate what's going on. Let's go back to the other alert that's been identified. So if we look over here, there's a second relationship with an alert defined to it, which is a relationship, from what I can see here, between an unknown system and my risk calcs application. So let's click through and take a look. So as we can see here, there's a new system which is unknown. If I get some details about it, the system first appeared in my environment on May the 6th, 2022, and has been there until September the 25th, 2023. So it's been in the environment for a very long time. It has executed 320 sessions, and also what we see, there's no NS record, so there's no reverse DNS lookup to give us a host name. So given that this system is unknown within my CMDB, appears to be unmanaged with no agents upon it, and doesn't have an NS record, it looks like this is an unknown system that's been active in my environment for some time. And let's take a quick look at the violations that were raised and when they occurred. So actually what we have here is two sets of alerts. The first one is because we've seen an access to a critical system, a tier 1 system, from an unknown or unmanaged workload. That's the lower alert. And then that also triggered a second alert, which is one that's encoded to ensure that RDP and other remote shell access protocols are only executed against servers from the hardened enterprise jump server. And if we look, this alert was initially triggered for both of these, because it was the same event, on May the 6th, 2022. Now, not wanting to labour the point too much here, let's take a final step in gathering the information we need to understand really what's happening around this unknown system. So what I'm going to do now is I'm going to click through on the unknown system, and I'm going to get an understanding of everything that it has done, or all of its observed behavior within the environment. So here we go. It's triggered lots of alerts. And this is the one that we've been investigating, the access to the risk calc system. But there's a couple of other really quite interesting events here. One is it's accessed the reference databases application over here as a SQL client. So MS SQL client access to the reference databases. And also, probably more worryingly, it's established an outbound HTTPS TLS connection to the internet. So potentially here we have a situation where data has been accessed within the predictive pricing application via an RDP session. A SQL client has accessed my reference databases, and an outgoing connection has been made to the internet. So what you can see in the last couple of minutes is how a policy encoded within the Relationship Cloud Rules Engine enables you to recognize behavior that's outside of your normal risk tolerances, and then how you can very quickly build a picture of the events that have occurred around it. So really, we've just been through two examples of the risk tolerances that can be defined, and also how the workflow to assess and mitigate risks can be streamlined. Additionally, this capability can also be used to meet CPS 230 requirement number 30, which is for the regular monitoring, review and testing of controls for design and operating effectiveness. So in this example, we demonstrated that the mandated use of the hardened jump server for shell access has been bypassed. Another potential example where this could be useful is where zero trust and segmentation policies can be reflected in the risk engine rules to ensure those policies are properly applied and effective. So Relationship Cloud really allows you to automate and streamline compliance with requirements 28 and 30 of APRA CPS 230. So this concludes our short video demonstrating how taking an automated and streamlined approach can transform how you approach and achieve operational resilience and become compliant with APRA CPS 230. Thanks for listening. Goodbye.